What's going on, AP Stats? Mr. Zamudio here. We're just going over the Chapter 13 Formative. Hopefully you've tried these problems out on your own, and then you're using this as a tool to help you learn from your mistakes or your successes. All right, so hopefully you've read that top paragraph there. We have a situation where these customers can come in and they have an opportunity to win a discount, $1 off, $2 off, 3 or 5. They're going to throw a little ball in, and then depending on which of these squares it lands in, that's what they will earn. So number one says, what's the probability that a customer gets more than a $2 discount? So if I just look at the boxes, there's only 3 of these that are more than $2. So this is just 3 out of a possible 10. So there is my probability that we're looking for. Number 2, what's the probability that a customer gets less than 2? Well, the only ones that are less than 2 are the ones that are $1. So there's $1, $2, 3, 4, 5. There's 5. About a 50% chance. Number 3, what's the probability that the first 2 customers both get a $5 discount? Right, so we want the first one to get a $5 discount and the second one to get a $5 discount. Remember, when you kind of think of the word and, that's a multiplication property. So the first one, we want to be a $5 discount, and the second one to be a $5 discount. So the probability that the first one is a $5 discount is 1 out of 10. And then the second one, we're still playing on the same table. It's still 1 out of 10. So really we're looking at 1/10 squared, which ends up being 0.01. It's like a 1% chance that the first two customers both get a $5 discount. Number 4, what's the probability that none of the first 3 customers gets more than a $3 discount? So we have 3 customers, and we want each of these 3 to get, none of these get more than a $3 discount. So each of these customers can get a $1 discount or a $2 discount or a $3 discount. They just can't get more than $3. Well, if I look at my table over here, all of these work except this $5 one. So there's a 90% chance that we get a discount that's not more than $3. So if I want this one to be less than or equal to $3, oops. There's a 9 out of 10 chance So just doing this multiplication, 9/10 to the 3rd power, and we get some number that I am trying to figure out in my calculator. Give me 1 second. .729. All right. Number 5, what's the probability that the first customer to win a $3 discount is the 6th customer that ends the store? Okay, so we're looking at 6 customers entering the store, and the 6th one has to be the first $3 discount. So what we want the other 5 ones to be is not $3. Okay, so the first 5 have to be not $3, and then the 6th customer has to be the first $3 discount. So if I look at my table up here, the probability that we get a $3 discount is just 2 out of 10. So that's 2 out of 10. The probability that we don't get a $3 discount is the complement of this. That's 8 out of 10. So really what we have here is 8 tenths times 8 tenths and so on. So it's really 8 tenths to the 5th power. We still have to multiply this by 2 over 10. So using your calculator, you get a decimal that will approximate this to be about 0.066. All right, and the last question here, what is the probability that there's at least one customer to win a $5 discount among the first 5 customers that enter the store? All right, this one's a tougher one, but we got this. All right, so the key thing here is that you recognize at least, right? At least one customer to win a $5 discount among the first 5 customers. So remember, when you see the word at least, think of the complement. We're going to want to do the complement. And the way I like to do this is I kind of like to write out what are the different possibilities that we're talking about here. So we're looking at 5 customers, and we're trying to see, hey, of those 5 customers, who won a $5 discount? Well, we know that we could have 0 winning, or 1 of those 5 winning. Maybe it makes more sense if I put out of 5. So we could have 0 out of 5 win, or maybe 1 out of 5 wins it. Or they could all win the $5 discount. It's probably really unlikely, but maybe they all 5 win the $5 discounts. So we are looking for the probability that at least one customer will win the $5 discount among those first 5. So we are looking for this probability that at least one of them will win. 1 of them will win, 2 of them will win, 3 or 4 or 5. Now remember, I tell you this is tough to calculate, so that's why we want to look at the complement. Let's just look at, hey, let's figure out this green probability and then subtract that green probability from 1 to figure out what is this total probability. So I am going to do the complement, 1 minus the probability that none win the $5 prize. So again, we're looking at 1, 2, 3, 4, 5. And if I want all 5 of these to not win the $5 prize, not winning, there's a 90% chance, or 0.9, 9 out of 10 chance that they don't win. So this is all of these guys not winning the $5. So it's 1 minus 9 tenths to the 5th power. And what you get is about 0.41.